Hi, welcome back. In this video, we're going to talk about how to solve trig problems. Before watching this video and before learning how to solve for a missing side or for a missing angle, we need to first be able to set up the problem. So if you haven't watched the video of Introduction to Trig, we want to watch that video first. Once you know how to set up the problem and whether it's sine, cosine, or tangent, solving will be the next step, which is what we're doing now. So, let's get started. Before we begin, I'm going to write the three relationships here that we spoke about last time, where sine is opposite over hypotenuse, cosine deals with adjacent over hypotenuse, and tangent deals with opposite over adjacent. So, ka, toa. Let's talk about solving this. As we set up the problem, we first want to identify the angle. Based on this angle, what is given to me? I am given this side across, which is the opposite side, and I'm given this piece, which is across from the 90-degree angle, the hypotenuse. O and H are related with so. That's the sine function. So, we're going to set up the problem where sine of the angle, theta, equals opposite over hypotenuse. This is the general equation that we're using. You don't have to memorize this equation. You're going to be provided this information. Now we plug in everything that we know. That was what the last video was about. Let's plug in the information. Inside the angle, we have 22 degrees. That's our input. The opposite side is 5, and our hypotenuse is x. This is going to be the very first step, no matter what problem we're working with. Identify the relationship, sine, and then plug in what you know, the opposite side and the hypotenuse. Now, to solve, what we're going to want to do is we're going to want to isolate the variable. And right now, we're currently dividing by x. The variable is in the denominator. So we first need to move it out of there. Since we're dividing by x, the opposite is to multiply both sides by x. This allows us to cancel the variable on the right. And now we have x times the sine of 22 degrees equals 5. Now that we're not dealing with a fraction, we can isolate the variable even further. Since we're multiplying x times sine of 22, to get rid of it, we're going to do the opposite. So we're going to divide by sine of 22 on both sides. This allows us to cancel things, and we're left with just x equals 5 over the sine of 22. Now, once you isolate the variable, this is the part that goes into our calculator. We're going to plug in 5 divided by sine of 22 degrees using the trig button, which is located in your calculator right next to the number 7. Or if you're using Desmos, you can plug in the calculator and you can find that you're going to end up getting 13.35. That is the length of the hypotenuse. Let's try another one over here on the right. In this scenario on the right, I'm going to be trying to find the measure of the angle. So now I'm interested in how do I find this angle? Earlier, we were trying to find the measure of the side. Now we're interested in finding the measure of the angle. Before we do that, I think it would help us if we do another example to find the missing side. We'll come back to finding angles here in a minute. So here, as an example, we're looking for the length of a missing side. Let's offer this one first. And as we get the hang of things, we can go and do the other example. Given the angle, what's given to me? Well, we are given the adjacent side, and we're given the hypotenuse, which in this scenario is cosine, right? It's a cosine relationship. So when I set up my problem, I'm going to have cosine of the angle equals adjacent over hypotenuse. The angle is the input, so I put cosine of the angle equals adjacent, which is 11, over the hypotenuse. This was literally the first video, the setup. Can you set up whether it's sine, cosine, or tangent? This video is about solving. Now, very similarly, to solve for x, to isolate the variable, we're going to want to multiply by x on both sides. And now we have x times cosine of 37. This allowed us to get rid of the fraction, but we still haven't isolated the variable. X is still not by itself. Since you're multiplying x times something, to get rid of that something, we're going to divide both sides by it, because division is the inverse of multiplication. So we're going to divide both sides by 37, cosine of 37, and that allows us to leave x alone. X equals 11 divided by cosine of 37. Once you've isolated the variable and x is alone, this is where the calculator comes into place. There's absolutely no way to solve this problem without a calculator. X is alone, plug the rest in the calculator. So we're going to want to plug in 11 divided by cosine of 37. And that gives us 13.77. Step number 1, identify what's given to you in the triangle around the angle that's provided so you can set up the equation. And then step number 2, isolate the variable. Very similar to here, we have an angle. Label what's around the angle. Right? I'm going to make this a little smaller. According to this angle, we're given the opposite side and we're given the adjacent. Opposite and adjacent is TOA. So this is a tangent function. Tangent of the angle equals opposite side divided by adjacent. The first thing is the setup. The angle goes inside as the input, 50.1. Opposite side is x, and the adjacent is 5. In this scenario, since we're trying to solve for x, but it's on the numerator, we just need to get rid of the 5 that's in the denominator. The opposite of dividing by 5 is multiplying by 5 on both sides. In this scenario, multiplying by 5, leave x alone. Since x is left alone, we can just plug this part in the calculator. So we get 5 times the tangent of 50.1. And that gives us 5.98. So when you're solving for a missing side, whether it's sine, cosine, or tangent, the first thing you want to do is find the angle that's given, label what's around it. Is it so, ka, or toa? Right? Now, let's talk about finding a missing angle. To find the measure of missing angle, we do the same setup. We identify the angle that we're working with, identify what's around it. This is the opposite side, and this is the hypotenuse. Opposite and hypotenuse is so. That's the sine function. So we're going to set this up with the sine function. Sine of the angle equals opposite divided by hypotenuse. The angle will always be the input, but since we don't know what the input is, we're going to put the variable x inside. You can leave it as theta, or you can put x since we don't know what it is. The opposite side in this case is 7, and the hypotenuse is 18. In a previous example, we would multiply by something to get rid of one of these two numbers, right? The 7 or the 18. But remember, our goal is ultimately to isolate the variable. Isolate x. The thing is, in this scenario, x happens to be inside the function. So how do we isolate it? I like to think of this as when we're talking about like the square root function. If I want to get rid of the square root, what do I have to do? I have to do the inverse of the square root function. And the function that's the inverse of square root is a square. This allows us to get rid of the square root by doing the opposite of the function. And that gives us 16, right? We're dealing with a function, f of x. We want to do the opposite of that function. And the inverse, if you remember back to algebra 1 or algebra 2, the inverse of a function has this -1. And that's exactly what we're going to be using to solve for x. When you're solving for x as the angle, sine is the function we're trying to get rid of. So we need to do the inverse of sine. So what does that look like? We're going to take sine, and we're going to put a -1 as the inverse. And we're going to take the inverse of the left and the inverse of sine, or if you want to think about it as the opposite sign, on the right. We're taking the inverse of the function to get rid of it. Just like we did here where it was square root and the square. We did the opposite to cancel. So we have sine inverse is the inverse of sine, right? That allows us to cancel those, leaving us with just x. And on the right side, we have the inverse of sine of 7/18. Now that the variable is isolated, we can plug that part into our calculator. The way to think about this, right, is we use normal sine to find a missing side. But since we're given the sides, right, we're given 7 and 18, I got to work opposite to find the missing angle. And that's what we end up using in the end, inverse sine. When you do that in the calculator, you're going to end up plugging it in. And what it's going to tell you, it's going to tell you the actual degrees. And in this scenario, the inverse sine of 7/18 is 22.89 degrees. Notice how we start with the same function. That's not a good color. Notice how we start with the same function. We start with sine and with sine. They both have the same setup. Sine is equal to opposite over hypotenuse, except that when you plug it in, here you're given the angle, and here you're not. Right? So the solving happens a little differently. Let's do another example to see if it'll help us understand a little bit further of how to find the angle. Let's talk about this example. We're looking for the measure of angle B. Let's go about finding angle B, which is right here. Identify what's around, as always. We're given the adjacent side, and we're given the hypotenuse. Adjacent and hypotenuse is dealing with k. It's a cosine function. So we have cosine of the angle equals adjacent over hypotenuse. This is always the original setup. Identify what relationship you have. Then plug in the information that you know. We don't know the angle, so we're going to put x as a variable. We do know the side. The adjacent is 4 and the hypotenuse is 5. Now, just like before, we're trying to get rid of the cosine function. So to isolate x, since x is the angle, to get rid of cosine, we need to do the inverse of cosine. That's what allows us to cancel things. Right? So I'm going to use a different color here. The opposite of cosine, or the inverse of cosine, is inverse cosine. We take the inverse of cosine on the left, and the inverse of cosine on the right. Whatever we do to one side, we have to do to the other side. That's what keeps the equation balanced, right? Those are basics of algebra. This allows us to cancel the cosines because we're dealing with the opposite function. X equals the inverse cosine of 4/5. It's important to know that what we're doing here is not multiplying it times inverse cosine. We're taking the inverse of a function. When we spoke about f of x, we're not saying it's f times x. F is a function of x. So here, cosine inverse is going to be the inverse of this function. That's why this whole thing cancels out nicely. Now, when you put inverse cosine in the calculator, because the variable is isolated, the rest is calculator. The inverse cosine function will give us 36.87 degrees. And that's it. That's it, guys. We're looking for the missing side or a missing angle. For this last example, I'm not going to explain it as full in detail, but I'm going to also set it up for you so you can see how it's very similar. Identify the angle. What's around it? We have the opposite side, and we have the hypotenuse. Opposite and hypotenuse, sorry, that's not the hypotenuse. The hypotenuse is over here, the diagonal, right? This is the adjacent. Opposite and adjacent is TOA. So we have the tangent of the angle equals opposite over adjacent. The angle in here we don't know, so the input will be a variable. And the output would be opposite over adjacent. Just as in the previous examples, sine, cosine, and sine and cosine, when you're solving for the variable and the variable happens to be the angle, to get rid of tangent, we need to do the inverse of tangent. And as we spoke about before, the inverse of a function has this -1 exponent. We're going to do the inverse tangent on both sides. On the left side, we have tangent of x, and on the right side, we have the fraction. The inverse tangent cancels with the regular tangent, and that's how we're able to isolate the variable, right? If we had x squared equals 16, the inverse of squaring is square rooting. That's how the square and the square root cancel. Similar here, the inverse of tangent will cancel with tangent, and that would just leave us inverse tangent of the fraction. Once x is alone, the rest is in the calculator. So we go to our calculator, we press inverse tangent of 4 over 13, and that gives us about 17.1 degrees. Feel free to pause, go back, check out these examples again. We're either finding for a missing side or a missing angle. And if we can understand the connection between them, right? The setup will be based on the picture. How we solve and how we go about the rest is based on what's given and what's not given. If we're given the sides, we're going to use our regular tangent. If we're missing the angle, we're going to eventually end up with the inverse of whatever function we worked with. Inverse sine, inverse cosine, and inverse tangent. All right, guys, that's just about it. If you have any questions, please feel free to come and talk to us in person. And as always, calculator.